So in my first Lerdge mainboard video, I started out that video believing that the stepper drivers that board came with actually came in UART mode. And what that would have allowed us to do is from the Lerdge menu actually be able to set up the reference voltages on those drivers and therefore set the current. Well, unfortunately, by the end of that video, I realized that UART mode was not enabled and I just left it as is. Everything was running fine. Well, thanks to an observant viewer, I found out that something I was missing was that I actually should have gone in there afterwards and actually manually set the voltage on those drivers so that the current would be set correctly. Otherwise, I found out the stepper motors on this machine were really overheating and I didn't even notice because it was just going about its business. So as I go grab this machine and get it here on the table, let me explain to you what I'm going to do in this video to remedy the situation, because you've got a few options. So first of all, as I mentioned, we can actually just go to the stepper drivers with the tiny screwdriver and actually set the reference voltage just using the potentiometer on those stepper drivers. And that's the easiest way we'll do it, and that'll work really well. No additional soldering or setting up jumpers or anything like that needed. The next thing we can do is we can actually put those drivers in UART mode like we had hoped that they had become. And there's actually two different methods of doing that Lerdge provides, and I'm going to show you both of them. If we do that, we'll be able to actually then just go into the menu and make those changes. And that's really the best option, but as I mentioned, it does require soldering no matter which way you do that. And the last option I'm actually going to review is, well, what if you didn't even buy your drivers from Lerdge anyway and attempted to use drivers that come from a company like Bigtreetech, and those are already configured for UART mode? Will they work on this board and save you all that soldering? Well, that's what I'm going to find out right here on Kersey Fabrications. Let's get started. This video is brought to you in part by PCBWay. Now, when I first started using PCBWay for my printed circuit boards, I chose them because of their low prices for printed circuit boards and quick turnaround times, as well as their PCB assembly service, which was perfect for the project I was working on. But what I most recently learned about was the amazing PCBWay community pages, which you can actually go find projects you want to work on, have the PCBs made directly from PCBWay, and download the source code to build your own version of those projects. Not only that, PCBWay hosts contests directly on their website, such as the latest Raspberry Pi Pico contest, where you can get a Raspberry Pi Pico just for participating, or one of 10 other awesome Raspberry Pi prizes. You can find a link to PCBWay in the description, as well as a direct link to their community page. Thank you to PCBWay for sponsoring this video. Now let's get right to it. So while you were watching that intro, I went ahead and plugged in this printer and got it ready to go. So the first thing we're going to do, let's cut it on. I'm going to print a benchy here at a relatively decent speed to get these motors heated up relatively quickly. And we'll see exactly how hot they're running just after printing, maybe an hour, a little less than an hour. We'll see how hot they get, and that'll demonstrate exactly what the problem here is, and then we'll have a baseline to go off of when we actually start doing the modifications to make sure that we're actually cooling down those steppers like we expected. So let me get the benchy going and we'll take a look at what the stepper motors are doing. All right, so here we are. We're about 80% into this print job. We're at 48 minutes, so this thing's been printing for quite a while. Let's go ahead and check the temperatures on all of our stepper motors, starting with the x-axis. So here we go, we have about 67, 70, we're somewhere around 70 degrees, which is probably the upper limits of this stepper motor, and it's definitely too hot to keep your finger on. On the y-axis, we are at not quite so hot, it looks like for some reason, maybe 40 degrees. Yeah, 40 degrees, and you can definitely tell a difference, but you still wouldn't want to stick your finger on that for too long. All right, there we go. You find the sweet spot and we're more allowing, so you find the sweet spot and you're about 57 degrees or so, so approaching 60. And on the Z-axis, 48 was one I saw, 54. So, and these motors aren't even doing much, but they have a lot of current available to them and they're using them. And then the final one, again, about 50, mid 50s on here. Well, I've got, did I get a, yep, there's a 60. So these are running extremely hot as well. So we have about all of our stepper motors running mid 50s to the 70 degree mark, 70 usually being about the limit that you're going to have on your average stepper motor. So definitely running way too hot. If you are seeing the same thing on your printer because you've already installed the Lerdge, or if you have a different printer entirely and you're seeing these sort of temps, then the rest of this video is definitely going to be for you. So what we're going to do next, I'm going to shut this down, or maybe even let it finish this at this point, but I'm going to get done with this print, and then I'm going to go ahead into the first method we're going to do, and we're going to actually use the steppers that it came with, unmodified, and we're going to ingest the voltages on them using the pots on top, pots being potentiometers. So I'm going to have to flip this over or something, some way where I can actually access those stepper drivers while the printer is turned on, so that I can actually get to those voltages, measure them while I'm actually making the adjustment. So I'm going to figure that out. I'll be right back. Oh, and one more thing I want to mention, if it's coming through on the mic, if you'll notice that when you have too much current going to your stepper motors, you're actually going to have a louder printer, and I think that's coming through here. Things just don't run as smoothly if you have too much current going to those motors. So I hope that comes through here once I have everything turned down, that the printer also runs a little quieter, of course not counting my fans. So I managed to get everything set up on its side, even with the big power supply. So this is the beautiful shot I've got for you of the main board and my multimeter all set up and ready to go. As you can see, this main board is populated exactly like it was in the other video. I have all 6 of these stepper drivers going. You'll notice, of course, one of these not being populated for that second extruder. So let's go ahead and take a look at how we do this. So first thing, what I've got my multimeter set up here, and I've got it set on 2 volts. If you have an auto sensing one or a different range here, make sure you set up that range. We will be going underneath the 2 volt mark for all of our measurements today. So what we want to do, first things first, we need to actually attach the ground lead, the common lead, whatever your multimeter calls it, to a ground wire on the DC rails. So for me, I've got it attached to this ground pin on the MOSFET, and this is just as good as anywhere attached to the board. Now, if you don't have the alligator clamp type probes, you're going to have to just hold these on. If you've got the typical, you know, pointy ended probes like this one, you'll just have to hold them on yourselves. Find a ground. It can be one of the grounds over here, or it can be the ground like up here. These are all good. Just find a good DC common ground location. Now, what we're going to do now is we're going to probe these points here. You see these little screws on the bottom of our stepper drivers. We're going to probe those to find out what the voltages are. Again, if you have the standard probe types, the pointy probe types that come with most multimeters, this method is not going to work for you. You're going to have to probe and then change, and probe and then change. But if you have alligator clamps and then some small screwdrivers like this, you can actually put those together and then be able to actually sense the voltage as you're moving it. This is a terrific way of doing this because it'll save you a lot of time. Just make sure if you do this that that alligator clamp there doesn't touch any other metal so that you don't short anything out. So what we've got here, we've got X, Y, Z extruder, second extruder, and second Z. So what I want to do is, as I probe these, I expect these initially to be at 1.25 volts because that is what it should be shipping as. And as we see right here, that is 125 on the dot. This one here is 126, really close. 1291, 1287. This one's not going to matter because it's not hooked up, but 125, and we have a 1.3. So they're roughly all 1.25 or higher. So what I'm going to do is I'm going to set these to currents that I've used on other stepper drivers on the Ender 5 Plus and I've had very good results with. So I'm going to put these up on the screen as I do them. So for X, I want 0.65 amps, and that's going to be 0.739 volts. I'm going to come in here with my screwdriver, and I'm going to turn it down. Other way, as you can see, so it's going to be to the right. So that's pretty good. 0.738. And on the Y, I want 0.8 amps, and that is going to be 0.909. There you go. You can be exact as you want. I'm going to leave that right there. Next one, I'm going to do 0.65 amps again, so that's 0.739. .7 for, I'm going to leave it right there. Okay, for my extruder, I am going to do 0.8 amps again, so 0.909. Okay, I'm going to leave it right there at 0.904. And then I'm just going to go ahead and do the second extruder, even though it's not set up at the moment. Let's go ahead and set it to where it should be. Okay, I'm just going to leave that right there. And then for the last one, this is another Z motor, so it's 0.65 amps or 0.739. Okay, I'm going to leave it right there. So there we go. I am all set up here now. So, next thing to do, believe it or not, I'm going to have to flip all this back over, get all of my wiring hooked back up, and I'm going to go ahead and do another benchy test print. Going to make it to about the same point in the print, about 40 minutes or so. Go ahead and take a look at how these stepper motors are all doing, making sure that we're all running cooler just like we'd expect. Now, one thing we need to do if we're going to be running these stepper motors in standalone mode is set up our drivers accordingly in the firmware. So we're going to click on the settings down here. We're going to click on motor, then click on this little Trinamic icon down here at the bottom. And then for each of the drivers we're running in standalone mode, we need to click on that driver, TMC2209, standalone. As you can see, this gets rid of all the options and lets the firmware know that it does not have control over that driver. And again, we'll have to do those for each of the different drivers throughout the firmware. But we need to do that just to make sure everything's set up properly. Then we'll be ready to print. So here I am at the 74% mark and about 41 minutes into this print. I'm going to see just how these stepper drivers are doing and how that is affecting the stepper motors. So first of all, I can tell you that these stepper motors are warm at best. So I can tell you without even measuring that they are doing way better than before, because before I couldn't even touch any of them for more than just a touch. So let's find out exactly how they're running temperature-wise. So the X is a little warm to my touch, and that amounts to about 34, 36, 37 C max. So that's an incredible decrease in temperature. And then if we go to our Z motors, now these are pretty much, I wouldn't say cool to the touch, but they're not warm at all. They're pretty much room temperature. Yeah, we're talking about 25 C on that one, 31 C, 28 C. Yeah, 31 C at most on the sides of these. So these are definitely running cool. And the Y motor, getting warm, but I can keep my hand on it without any problems. We are talking 32, 36, 37, 38 most. So definitely took care of our overheating problems on these steppers, and I can tell you already, I am no longer hearing that that grinding sort of sound that we were hearing before on the movement of the printer. I'm still, of course, hearing the fan noise. That's a separate issue entirely, but I'm no longer hearing those movement issues that I was getting on this printer before. So definitely setting the stepper drivers to those lower reference voltage which is resulting in a lower current to our stepper motors, is definitely fixing the issue we had with both temperature and noise. So solution number 1 is a complete success. Now it's time to move on to solution 2, which is definitely going to take a little bit more work. So solution 2 is where we're actually going to be setting these stepper drivers up for UART mode. So I'm going to have to pull this apart, actually pull out all the stepper drivers, because we're going to want to do this to all of them. And then I have 2 methods to show you. Both require soldering, and we're going to take a look at the results. Let's get going. Okay, I have all of my steppers here on the workbench. Let's talk about the first method. So I'm going to pop up here on the screen the graphic that Lerdge has provided, and all this method requires is that we take 2 of these pads and bridge them together with solder. Now, if this is going to be too difficult for you, if you're not comfortable doing this soldering method, then the second method may be a better option for you. So you may want to just watch this method, see what you think, and then we'll go on to the second one. So first of all, I've got my soldering iron here. I want to clean off the tip, get a little bit of solder on there, but first I need some flux on here so that the solder will flow correctly. And so I'm going to take my flux pen here, and I'm just going to put a little bit of flux on those 2 pins. Now that was a little bit too much, but it's easy to clean this off after I'm done. So there's the flux. Let's go ahead and get a little bit, I've already got a little bit of solder on there. Let me clean that off and do it again, some fresh solder. All right. Now again, I'm going to show you here how I do this, but let me see if I can get that little dab of solder onto both of those pads. Then I'll have to take a closer look at it to make sure that it bridged correctly. All right, I think that may have done it. Let me take a closer look. Yep, so on mine, that is successfully bridged between those 2 pins. Now I'm going to do half of them one way, half of them the other, just to make sure that both methods work correctly. So there's 1 down. Let's do 2 more just like that. Okay, that's good enough for me. That's 3 that way. Okay, for the second method, we're going to take these pins that came with the stepper drivers and or the main board, and we're going to solder them onto the pin headers that are already onto the boards here. Now you'll see in the instructions that they actually say to solder 4 per board, but we technically don't need to do that because we're actually only going to be hooking 1 of them up. So for the sake of this instruction and for just the easier solution, I'm going to actually take some of these and I'm going to actually snip them apart, and then I can just use those. Now if they break when you're snipping them apart, don't use those, but usually cuts pretty clean. Alright, so now that's enough for 2 boards. Let's get 1 more. And 1 of them flew across the room, but we have 3. So let's go ahead and get these right here. Now, according to the instructions online, we only need this bottom pin down here labeled RX. You can see that right in this area. That's going to be the only pin that we need to hook up to the board. So that's going to be the only one I worry about soldering on. So we're going to put this down here, and then we're going to have to find some way to hold that while we solder this. Now I think the easiest method is going to actually be able to take one of these little jumper wires, if you have them handy, which you are going to have some of these handy for this method, and I believe these do not come with the board. But I think the easiest way going to be to do this is to use this as a bit of a glove so that we can hold this and not get burned. And again, this should be just that RX line right here, and you should be good to go. We're going to hold that straight. Again, just as we did before, a little bit of flux on the board. Let's move these out of our way while we do this. And then we can just solder that on right there. So, going to now be able to set this up. And this may not be the best method to do this. Obviously, if you have other methods of holding these in place while you're doing this, please leave them down in the description for others to follow. But I'm going to use this method. I'm going to make sure I'm holding it as straight as possible. And with the flux, this should be pretty easy to solder on. Let me just get this at an angle where you hopefully can see what I'm doing. And just like that, we should have our first pin ready to go. Let's find out. Looks pretty good to me. Looks like we have a good connection on that one. If you're worried about this little bit of solder or a little bit of pin sticking off, you can use your snips a little bit to clean that up. And there we go. Now we're going to do this for our other two that we have left, and then we should be all ready to go for plugging these back into the main board. And just in case you melt one of these while you're using this to hold on to them, I wouldn't use the wire that you're actually using to do this because you could be melting that connector just like you see here. But this is still a good way to hold it if you don't mind sort of spinning one of your connectors. There's the last one. You know, I can straighten that up a little bit if I want to. And there we go. I've got 3 with the pins on the RX. And I have 3 with the jumpers installed. So now I'll go back to the main board and we'll actually show you how to plug these in. Okay, so back at the board. Now what I'm going to do, I'm going to show you how to hook it up each one of these. And we're going to start with the ones that just have the soldered pins rather than the ones with the wired connector. So what we want to do with this is we're going to remove all but one of the jumpers on here. All right, there we go. There's 1 off, 2 off, 3 off. And then for this last one, we're not going to actually take it off. We're just going to move it over to the front 2 pins just like that. Then we can take our modified stepper and we'll plug it back in just like it was plugged in before. Pay attention to the color coding. We got blue on one side and black on the other. And we can plug that right back in where it goes. Now, if we are using the wired technique, the ones that actually have the wired pin that we installed, then what we're going to do is we're going to remove all of the jumpers, leaving none of them behind. All right, then we're going to go ahead and plug in our steppers, again paying attention to the color coding. But just so that you can see this better, we're going to need one of these female to female wires that you can get pre-made, or you can make these yourself. But let me pull off one of these. Again, we have the female end on both ends. We're going to go ahead and attach one end to that jumper that we installed right there, and then we can put it back in here just like that. Now this pin, the other side of it, will go to this front pin here, basically where we installed the jumper on that other one. So as you can see, depending on the method, we have this jumper here if we did the soldering underneath, and we have this wire here if we soldered on just the pin header onto here. Now for testing purposes, I'm going to alternate these all the way down, and then I'll show you what it looks like. Now obviously, one thing you can see here is this probably would have been better if it was a little bit shorter, but this is pretty easy to clean up. Okay, there we go. I have them all installed. Again, jumper, wire, jumper, wire, jumper, wire. Now, obviously, you wouldn't want to do it this way. You'll want to do them all the same method, whichever you think is better for you. But I'm just doing this for demonstration purposes. Now, I'm going to clean all of this up. I will need to turn on my printer, and then I will need to reset these reference voltages back to the 1.25 volts. So if you saw the first part of this video where I was setting these reference voltages to the correct voltage, I now need to turn them back to a known voltage for the firmware to know where they're starting at. So I'm going to set all of these back to 1.25. I'll show you here real quickly, but that's what I'm going to do after I clean up these wires with some zip ties. Okay, so everything cut on here like I expected. Now I'm going to do just as I said. I'm going to set all of these reference voltages back to 1.25 volts, being very careful not to touch anything else. Now technically you can leave these at pretty much whatever you want to, as long as you know what they are to put into your firmware. I'm going to try to make this easy on myself by turning them back to where they were, because the firmware is already set for this. Alright, there's 1.25. Alright, there we go. All of them set back to their reference voltage. Now I can flip all this back over and we'll take a look at the firmware. Cut it back on. We should get our Lerdge screen. There we go. And then we are back into the configuration menu. I'm going to use my handy dandy stylus it came with to navigate. Now let's go back into settings. And we are going to go to motor. And then see this little icon down here? That's the Trinamic icon. We're going to click on that. Now I showed this in my initial configuration because I thought that UART would be enabled, and it wasn't. So we're going to show you how this works now. So if you go into the X motor, you can select your driver type. Now, there we go, 2208. 2209 is what I have because that's what I bought with mine. Now you can set it up with stealth chop or spread cycle. Spread cycle being the louder and more powerful version, and the stealth chop being the quiet version. Now, if you were running these the way that they came, these need to be set to standalone. I'm going to set all of mine to stealth chop. The micro stepping should be 16. There we go. The drive current. These are the same things that we saw before. So notice I told you about setting my VREF back to what we had initially set it up for. So I set them back to 1.25, and this is where you have this number right here. And then these currents are the ones that I showed you at the beginning of the video. So for my x-axis, I want 650. And the holding current, we're going to just leave these as defaults for now. If you find that when your steppers are not moving, when they're idle and they are not staying where they're supposed to, then you would adjust those upwards. Anyway, let's go back into this menu and do less talking, more configuring. Again, that's it for that screen. Sensorless homing, we're not using that, so I'm going to quit. And then I'm going to go through each one of these, checking my settings, making sure that they're correct. These are all correct here. Notice I'm using 800 as my current for my Y. For my Z, these are going to be set for 650. For my E, I'm going to have it set for 800. E1, I don't have an E1 on here, but if I did, it would be 800 also. So I'm going to just set that one for the heck of it. And then EX, which is my second Z, is going to be the same as my first Z, and I'm going to set it for 650. And so now you can see all these are 2209s. If all went to plan, we should be ready to print now and see if everything moves the way we expect it to. So let's get back up top, get to the wide shot, and see how the printer does. All right, so let's give this thing a shot, see if I have everything configured correctly, or see if I missed anything. I'm a little worried about those micro steps, for example. So let's see if everything moves correctly. First thing we're going to do is just go into our settings. We're going to press the home button and hope everything goes to plan. Looking good so far. If it ends up in the middle, I think we did a good job on the micro steps. Looks like the center to me. Everything's super quiet, so the silent stepping is working. Yeah, that's working great. Okay, so now what we came here for, time to start that Benchy up again. Wait 30 to 40 minutes. I'll be right back here with you, and we'll check the temperature of our motors. All right, so the print has been running now for about 33 minutes. Now let's take a look and see how the temperatures are doing on our stepper motors. So we'll start with the X motor. And we are running at about 56C. Somewhere around 50C, 47 on this side, 50, 55, somewhere around that. So let's go ahead and check out some of our other motors. Let's do our Y, 48. Just get it from a couple of different A's, 43, so somewhere in the 40s, 53, 54, so again, somewhere in the 50s. We're going to go ahead and check out also our Z motors. So these are also in the 40s. Yeah. 40s on the side. Let's check out this one over here. 36, 37. Yep, 40 on those. And let's, I forgot to check the extruder motor before on the other test. I'll go and check it on this one. This one's running also around 40. Just doing a touch test, I would say that we are still running really warm, but we're definitely not running as hot as before. So what's interesting to me about this test is in UART mode, with the settings that we have set here, we seem to be running somewhere in between. They're not running as cool as when we were running just standalone mode with our voltages turned down, but they're not running as hot as when our voltages were too high. So we're somewhere in between. Now what's good to know is that these temperatures, while not fantastic, in the 50s, mid 50s at our highest here, are not fantastic. We definitely want to stay under 70 though, so these are not great, but they are acceptable. I will have to say I can only assume UART is running at this point, and just to make sure, what I'm going to do is after this test is done running, after this Benchy's off the plate, what I'm going to do is I'm going to go ahead and make some changes to the steppers. I'm going to turn off the stealth chop mode, turn on the spread cycle, and we are going to then test and see if that changes the noise level, because if that works, then we know UART mode's working, and these are just the results we're getting. So let me let this finish. I will come right back. I will change the settings in here. We'll check the noise level. As you can hear on this one, one thing I can say, not counting the fan speed, is the printer's running really, really quiet. So stealth chop, if everything's working, stealth chop's definitely on, because nothing except my fans are really making noise at this point. All right, so if we were wondering if it is actually working, turning it on spread cycle definitely answers that question, because the printer is making a lot of noise now. During the homing operation, I was able to hear the Z motors. I'm now able to hear the X and the Y motor, so definitely it seems like all of my steppers are working properly. We're just getting higher temperatures for some reason. I'm guessing it's due to the way the internal drivers are working. So that's it for that. Let's go ahead and look at my final option. What happens if we replace the Lerdge stepper drivers with some of these Bigtreetech stepper drivers? Are they even compatible? Let's take a look at the spec sheets and find out. So in front of me here, I have the two data sheets / manuals for the drivers that we're going to be comparing. On the left, we have the TMC2209 Lerdge data sheet, and on the right, we have the Bigtreetech 2209 version 1.2 datasheet. Now, when we're comparing two products like this and we want to see if they're compatible, the main thing we want to look at first is the pinout of the two devices. So we have this table here for the Lerdge. This shows which pin is which. We won't go into a lot of what each pin is, but we do want to compare them to this diagram over here to see if they are similar, to see if they are at least connected in the same way. And if you do a look here, you'll notice that the pinouts are almost identical. In fact, the only real question I had was whether the motors were wired the same, because they're labeled differently in our table and our diagram. And come to find out, when I looked at the details down here at the schematic, they are wired the same. Even the motor pinouts are the same. So then the question I had, is this solder bridge that we had to make down here on this driver going to be the same communication for UART as the Bigtreetech driver is by default? And from reading through this information, I was able to determine that yes, indeed, it is going to be the same, or to the best I can tell, it's going to be the same, and they do have that connected to the same pin. So just using the jumper method that we saw before, this Bigtreetech driver should work the same as this TMC 2209 with this jumpered bridge. And then the last question I had was, what is the RSense value for this driver? Because we're going to need that information for our firmware, and it is the same 0.11 ohm RSense that we have on this driver. So from a functional standpoint, these look identical to me. So what we're going to do now, flip over the printer one more time. We're going to pop this in. We're going to set that reference voltage to the 1.25 or thereabouts, and then we'll be ready to test this in the printer, see if it works exactly the same as the Lerdge counterpart. Okay, and one more time, let's go ahead. We're going to remove this X stepper right here, and we'll set that aside. Now, if we're going to be doing it with the Bigtreetech steppers, we're going to need that single jumper installed, just like we did before, which is on this last pin on the right-hand side. Now, in terms of orientation, it's going to be oriented exactly like the Lerdge drivers were, with the potentiometer on top and then facing this way. The black set of pins, and I know this is a lot of focus, I'm sorry, but the black set of pins here is going to be on the same black side as was before, and then the red's going to be on the blue side. And then we can push that in right there, and we should be good to go. Now the only thing we need to do is power it on, and then we can set that reference voltage just like we did before. Oh, helps if you plug it in. All right, now let's power it on. There we go. Now let's check that reference voltage. I have, again, the black wire attached to the ground, and I have my red lead attached to my screwdriver. I'm going to go straight down onto here, being careful not to touch anything else. And we're already at 1.28, which is exactly like the other one. We're just going to go a little bit lower, get it as close to 1.25 as we can. There we go. I like that. 1, 2, 4, 5. We are set to go. Let's flip this back over, make sure everything's configured correctly. It should be, and then we can do that test print again. Let's see how these run compared to the Lerdge drivers. All right, so one last test print, and let's see how that Bigtreetech stepper is doing on my x-axis. So looking at the temperature just as before, 40 degrees, 42 degrees, 44 degrees, 48, so 49. So just about 50 degrees Celsius on the x-axis with the Bigtreetech driver, which is really what we would expect since the stepper drivers are pretty much identical between these two manufacturers. The only difference is, of course, that the Bigtreetech was ready to go out of the package. So with all of these tests in hand, which configuration should you use on your printer? Well, let's cut back to the wide shot and I'll give you my final thoughts on what we saw in this video today. So at the beginning of this video, we started out with some stepper motors that were running way too hot for comfort and most likely way too hot for specs. Now over the course of the video, we've solved this problem 3 different ways. Now first of all, the easiest solution was to simply get a hold of the stepper drivers using our multimeter, resetting that reference voltage down to the values that we needed given the given formula, and we ended up with cool standalone steppers that actually turned out to be the coolest solution of everything we came up with. Now, the only downside to that method, though, is that we have not gained full control of those stepper drivers by enabling UART mode, which from that point we can actually modify different settings in the firmware without ever having to flip back over the printer. That gave us access to things like the current of the drivers, as well as whether we wanted to run in silent mode or spread spectrum mode, which would give us more power. Now, if you want to enable UART mode to get a hold of those features, we had two different solutions. First of all, you can go with the Lerdge drivers, and then you will have to do some soldering. The first method of jumpering that pin on the bottom using solder will give you kind of the nicest solution. It looks the best. There's no extra wires that you have to run, but it's probably the most difficult from a soldering perspective. It's very small pins, and if you haven't done that before, it could be very difficult. The second method for that driver is to actually use a jumper pin, which it actually comes with, solder that into place, and then just use a jumper wire, which can be easily purchased, to run that down to the board, and that will give you UART mode just exactly the same way, but just with a little bit extra wiring. Then we saw once we went into the setup, we had full control of that driver. Now, that's how those Lerdge drivers ship. They ship in standalone mode. If you want UART mode, you actually have to do that soldering yourself. That brings us to the second UART option, which is to actually buy your stepper drivers from Bigtreetech, because they ship with UART mode already enabled. And as we saw in our last test, they are a drop-in replacement for those Lerdge. So if you haven't bought your board yet, or you simply want the easiest option, you can buy those Bigtreetech drivers and you'll be ready to go. So I hope this video gave you a better understanding of how these TMC stepper drivers work, and specifically how they work on the Lerdge mainboard. Now, just as we usually do here, I want to thank my Patreon supporters for everything they do. Their names are running across the screen here because I always like to thank them at the end of the video. And we've got a little bit more on the Lerdge board coming in the future, so stay tuned. If you've got one of these Lerdge boards, I've got a little bit more to cover. This was an important one to cover for me, obviously, because I think this was a safety issue and it was something that I missed in my original video, and I'm always here to try to give you the most complete coverage of anything I do on the channel. So thank you again for watching. I'm Chris, and this has been Kersey Fabrications, and I'll see you next time.